Hi guys, in today's session we'll be speaking about large language models. I would want to give a general overview on what LLMs are and a couple of buzzwords which we use in our day-to-day life, like tokens, parameters, autoregressive, LLM, SLM, things like this. So to get started, what is a large language model? Now we all know an LLM is a neural network which is trained on massive text corpus. And LLMs are called autoregressive. So this is one keyword which we are supposed to keep in mind. What autoregressive means is, let's say we have this sentence, I am working in dash. LLM tries to predict the next word, working in AT&T, right? Now, then again, it tries to predict the next work, working in AT&T. So again, the next word. So like that, at the end of the sentence, you might get something like this. So LLMs mostly, so if you remember the 2022 historic LLMs, they used to take text as input and give text back as output. So in input, you'll be asking a question, and output, they would be responding something. So when you ask something like, where am I working? This is the input. Now it starts predicting. It's trying to predict the next word. So as an answer, it would like to start with you, and in the next run, it will predict R. In the next run, depending on you are, it will predict working. Depending on the three words, you are and working, it predicts the next couple of words which are you're working at AT&T. So now this is called autoregressive. But why? It's because you're starting with nothing and you're predicting the first word, and depending on the first word you're predicting the second word, and depending on the first two words you're predicting the next couple of words. So it's automatically regressive, and this continues until it feels like this is the end of the response. So it's called, the end of response also has a token. It's called EOF token, end of file token. So whenever that token is predicted, it stops generating the text. So in our case, the full stop represents that. So this way, every input text is converted to input tokens. Depending on the input tokens, we predict the first token, and depending on the first token, we predict the next couple of tokens. So coming back to our presentation, now this was back then. You used to get text, you used to give text in, and you used to get text out as output. And this includes GPT-2 and 3, which came out in 2022, early BERT models, and they are of single modality. That means they only used to work on text. They used to have a context window of 1000 to 8000 tokens. Now, what's different now? We now have something called as multimodal models. That means instead of just text here, they have the capability of taking multiple things. That might be text, audio, images, some models even take videos. So large variety of input modalities. So if something like this can be converted into tokens, where can be assigned a token, am can be assigned a token. If you guys, if it's confusing when I'm talking about tokens, you don't really have to worry about it because I have a slide on tokens, so we can discuss it later. But yeah, at end of the day, your text or your input is getting converted to tokens, and depending on those tokens, you're getting the output itself in a couple of tokens. Same way, when you send audio, images, and videos, just like how each word has a token assigned to it, we try to calculate the tokens depending on the pixel values of an image. Or maybe the audio, uh, even audios have some values, right? Depending on those values, you try to create tokens out of it. Same goes for videos. So all of this, end of the day, they're going to get converted to tokens. Once they're tokens, they can be predicted auto-regressively. So that's how the current multimodal LLMs work. Now, let's talk about parameters. So we keep hearing this term a lot. For example, we must have heard Opus 4.8 consists of trillions of parameters, so it's a good model. Or maybe GPT 4.1 has 900 billion parameters, so that's why it's a pretty strong model. So we keep on talking about parameter as if it refers to the power of an LLM. Yeah, it's true in one sense. So if you see, I'll show you guys the transformer architecture. If you remember, I've shown this in the first session. So this is the architecture. Each block has a couple of mathematical formulas which are used to calculate matrices. So this block has a couple of formulas. This block, that means the output is a matrix. You have a matrix here, you have a matrix here. Same way you have matrix at for every block here. What do these matrices contain? They contain numbers. So essentially, when you're trying to predict a token auto-regressively, it's being predicted by multiplication of all of these matrices. So here, when you say you have 7 billion parameters, that means the total number of values in all of your matrices combined is 7 billion. So that means whenever it's trying to predict a token, the 7 billion parameters are being activated at once, and then you get the output by performing multiplication and dot product on all of these matrices. So that is what a parameter means. So when you talk about a model having trillion parameters, that means that is how intensive the compute is going to be at inference, because all of these parameters needs to be activated. They need to be multiplied with the input tokens. So this calculation takes time. That is the reason why you need GPUs for it. And that is the reason why we also call inference for LLMs is expensive at runtime. Yeah, so as you can see, we have embeddings. Just the embeddings. I'll talk a bit later about embeddings also. We have it on the same slide as tokens. So the embeddings contain 131 million parameters, and you have something called as attention. So if you remember this text, I told working here is predicted depending on the previous two words, U and R. Similarly, AT&T here is predicted depending on the four different words coming before it. So before predicting a word, it's trying to understand and look at what all words come before it. So that is what is called attention. Now, attention is also math. So it also contains a couple of matrices. And then you have feed forward networks. So in this diagram, if you see, yeah, you have feed forward networks here. So feed forward is something which comes after multi-hit attention. That is where you try to predict the next token. So even that contains certain values. And then all of these, so if you these two blocks you see, this is only a single layer. Now usually LLMs are not made up of a single layer, but they have multiple layers stacked up on top of each other. So you can assume 32 of such architectures stacked on top of each other, and all of those combined gives you the total parameters. So that is what it means here. The 32 layers of those the architecture which I just showed you guys, it's stacked on top of each other, and it gives 7 billion total by stacking all of these values. Now is the time. Let's talk about tokens and embeddings. So the sentence is LLMs love tokens. Now it gives certain token values. So I'll just show you guys the example. So the question here was, where am I working? Right? For an LLM, this will get converted into tokens. For example, 101, 1032, 1654, 902. So where was assigned 101, am was assigned 1032, I was assigned 1654, working was assigned 902. Where are these values coming from? I mean, you can just think of it is a result of training an LLM because it has looked at thousands and millions of words while training. It has learned to give a certain value for a particular word. So there are types of tokenizers. Uh, it doesn't necessarily have to mean that a single word becomes a token. So there are tokenizers which convert each character into a token. There are tokenizers which convert each word into a token. There are tokenizers which convert sentence into a token or subwords into a token. So there are different types of tokenizers. So I'll just give an example. So you can just simply type tokenizer and you'll have OpenAI's tokenizer, which will exactly show you how many tokens a certain text consists of. So for GPT-5 and O1 models, O1 and O3 models, if I type something like where am I working, so you can see there are 5 tokens. Where was a token, space and am together is a token, I was a token, working was a token, and question mark was a token. So you got 5 tokens. And when the LLM gives output as, now we have 6 tokens. You are working at 80 NT. So it has converted this entire sentence into a couple of tokens. Now coming back to our input and output, this is our output, meaning your output was 6 tokens, whereas your input was 5 tokens, if I'm not wrong. Right. Now, what happens after it gets converted into a token? Now, it has something called as a huge vocabulary where it defines the numbers. That means for the token 101, the value is so on. Right. Similarly, for 1032, the value is and so on. So, like that, for all of these numbers, you have certain matrices of a single dimension. So, this is called an embedding. So, this whole matrix is called an embedding. So, just to revise, you have text. This text gets converted into a token or tokens, since there are multiple tokens in a sentence. Now each individual token gets mapped to a vector embedding. So the output of this at the end will is going to be a two-dimensional array or a 2D list, which we've discussed. Right. I mean, I'm just copy pasting the same values, but you got the point, right? So it has a huge vocabulary matrix where each token is associated to a matrix, a one-dimensional matrix, and you can think of this as a dictionary. This is the key, this is the value. So like that, you extract or retrieve all the values of all of these tokens, and then you put it in a two-dimensional matrix. End of matrix. Oh, there is supposed to be another one, right? Since you have four words, four tokens, you got four embeddings now. So this is how a text gets converted to a vector embedding before it goes inside LLM. Now, once it goes inside, LLM will also give something like this as an output. And then you try to map it in reverse. So you extract the value, the key of this vector embedding, meaning the token, and then you get a couple of tokens as output again, and then you convert these tokens into text back. So here the flow is text to tokens to embeddings, right? Now here the flow is embeddings to tokens to words. So this is how an LLM takes input and gives outputs. So whenever we talk about input tokens and output tokens, this is what we mean. Now how do we calculate the cost? So I'll just ask GPT 5.5 cost in Google. So you got something like $5 per a million tokens and $30 per a million tokens. So output is usually more expensive than input. Meaning, if you're using GPT-5 and your input, so we've discussed before, right? Our input was 5 tokens and output was 6 tokens. Now, input is 5 tokens, output is 6 tokens. How do you calculate cost now? Cost is nothing but you multiply the input tokens with the cost per input token, and then you have to add it with the output tokens into cost per output token. This is it. This is how you calculate the cost. So for GPT-5, input is $5 per million tokens and output is $30 per million. So now how do you calculate the cost for this 5 tokens and 6 tokens? It's nothing but 5 into it's $5 per million. This is a million into you got 6 tokens into $30 per million. And when you calculate this, you get some value, and that, which is in dollars obviously, and that is the cost for this conversation. So in fact, I can demonstrate this as well. If I go to ChatGPT, hi, how are you? Okay, this is the input. Now I'll calculate the tokens for this. It has costed me 6 input tokens. Now this is the output, and this it costed me 47 output tokens. Uh, so what we need to do is 6 into 5. Okay, let's calculate per token cost of input parameters first. I will multiply this with $5. Sorry, 6 tokens. So this was our input cost. Now I will calculate the output cost, which was $30 per million tokens. And I have to multiply this with uh, 47 tokens because that is what our output size was. And now you add it with this because this is our input and this was our output. Uh, 0.0000. Okay, 3. So our conversation, which was hi, how are you doing, and the output of that LLM, this was the cost for this. So you spend $0.00144 for just this, and that's how you calculate tokens. So even when you're using Copilot, when it's asking you or it's speaking about input and output tokens, this is what it means. Yeah, this is what I just spoke about, how LLM cost is calculated. Input tokens into input price plus output tokens into output price. And I've given an example of Opus 4.8 for 8,000 tokens input and 2,000 tokens output. So you simply do the math per million and then you get $0.09 per call. That's how it happens. And this is an example of what a couple of uh, frontier model providers are charging us for their API usage. Now let's talk about, we know that Opus 4.8 is better than 4.1, but what exactly makes it better? So 4.1 was released in April 2025 and 4.8 just came out recently in May 2026. So that's like a complete year of difference, which obviously gives a lot of change, time for a change. So as you can see, the entire architecture has switched from a dense transformer to a hybrid mixture of experts. Even the training infrastructure, which is the GPU clusters, they have evolved over time. So Opus was trained on better GPU clusters, which have more compute and take less amount of power. Even the training data, over the course of time, Anthropic has figured out their models are being used more for coding, and they have a lot of data with them. So they have the capability of training their or architecting their training workflow depending on how what the users want. So they have the capability of introducing different adaptive thinking, dynamic workflows so that it can reason before answering. And what was the result? When GPT 4.1 has scored 28% on the SW Bench Pro, which is a benchmark, Opus 4.8 has scored 69.2%, which is a massive increase. Now, all of this has happened because of multiple factors, right? It can be GPUs, it might have been the way it has been trained, the architecture of the neural networks, or the data itself. They know what their users wants now. So depending on that, they must have trained it in such a way that it's more useful for training. Now, LLMs are one thing, but we also have something called as an SLM. So SLMs are usually language models which have small amount of parameters compared to these huge frontier models like Opus 4.8, GPT 5.5, and Gemini 3.1. So Gemma, Llama, and Mistral, they have parameters varying between 100 million and 10 billion. Even though their parameters are low, they're still pretty good when you're tasking them with a very specific task. So if it's coding, you will always ask it coding. Only then it can answer you pretty well. If you ask something different, maybe like sports or general affairs, it might not be that good. So that is the reason why SLMs are called as the specialist, whereas an LLM is called as a generalist. So SLM is also usually cheaper on inference and cheaper to train. So as you can see, it's 5 to 20 times cheaper to operate at scale. LLMs are quite expensive. As you can see, they take around $5,000 to $50,000 at enterprise scale, and they only run on multi GPU clusters. But the SLMs, they can even run on our local machines, our local laptops. So that is the reason why SLMs have become quite popular now. So we're done with the presentation. Now let's talk about how we can use these models. I'm talking about API keys. So when you go to OpenAI API, it'll take you to the API platform. When you go to developers here, start building, API dashboard, you should go to API keys. And here, so I've already created an API key here. And this is where you can create a new API key. So you give the name, you create, and then you get a huge cryptographic text. But this is not free. So I have loaded $5 as credits here, as you can see. And this is my balance. So whenever I invoke the API, we've discussed our input and output costs, right? So all of those get calculated. And you can also track the cost at the user section here. So this is how almost every single provider provides you their API endpoints and their SDKs for building with their models. So similarly, if you go to Anthropic's API platform, yeah, this is my dashboard. Again, this is also not free. As you can see, I have $15 loaded in credits here. And you can also go to API keys and then create an API key. So I have a lot of API keys. So this is how you can create API keys for pretty much any frontier model. The same goes for Gemini, Mistral, or any other things. So I'll talk about invoking this. So this is something which I did not write. This is something readily available on the internet. So if I go to OpenAI API docs, so they have an API documentation. And then when you go to quick start, they'll tell you all the steps. First, you're supposed to create an API, and then you're supposed to put it in a .env file. So as you can see, this is my .env, and obviously you cannot by the time you're watching this video, all the API keys will be disabled anyway. So, but this is not something which is supposed to be exposed outside. So you have OpenAI and API keys, and OpenAI and Anthropic's API keys set in a .env file so that it is not tracked in our version control. And you can select the language. So I'll select Python. Now you're supposed to pip install it. So let's install it. Pip install OpenAI. So I've already installed it, so it's going to be really fast now. Right, now what is the next step? The next step is, so this is an LLM client. Right, now I've simply copy pasted, but there is one small addition which is nothing but loading all the environment variables present in this file into the environment so that this can pick it up. So we've discussed classes and objects before, right? Similarly, this is a class. Now we are importing it from the package which we just downloaded. And once you create an object, now you can create a response from it. So client is the name of the variable which is storing this object. Now this object has a couple of methods and variables, right? Or attributes. Now inside client you have a method called as responses. Inside responses you have something called as create. So when you do create and you give the model parameter, 5.5 is expensive, so I'm going to use 5.4 mini, and you give some input, and then you simply run the file. So as you can see, it has given me an output. So yeah, write one sentence bedtime story about a unicorn. So that it has written a story. So this is how you can integrate LLMs into your Python workflows. And this is going to be the base for your next 9 weeks, because we'll be building very cool automations and chatbots using this LLM client. So we have OpenAI. Now I'll show you Anthropic. So you need to follow similar steps for Anthropic as well. And you go to quick start, or API reference. Okay, we have to search. Uh, uh, uh. Yeah. So we have to select Python again. We have a couple of other options: TypeScript, C Sharp, Go, Java. But we'll be selecting Python. We already have this in our .env, so there is no need to worry about this. And then we need to, okay, this is about creating a virtual environment which we have already created. The next thing is pip install Anthropic. So I'll copy this, I'll go to my terminal and paste it. So I've installed Anthropic. The next job is to paste it. So I've pasted whatever I've seen, but then again we are supposed to load our .env. And again, Opus is quite expensive, so I'm going to turn it into Sonnet 4.6. And the API reference is a bit different. So here it's like it depends on model to model and how the code is written, right? So here it's a small, simple create API reference. Here you're putting the max number of tokens it should take. If it exceeds more than 1,000 input tokens, it's simply going to reject the request. So you have more control here. and you have the role of user and the prompt. Let's execute this. Python, and the name of the file is Anthropic. So yeah, it takes 1 or 2 seconds to give output because this is an LLM call, right? So yeah, it has given us an output. So it's quite messy, but you can probably access this using message.content.text because I've seen a text here in between somewhere. Yeah. So inside text, we are actually holding the information. So yeah, that's it for this session. We've learned how to integrate LLM clients in Python, which acts as the foundation for the next 8 weeks and all of the following sessions. We'll be creating a lot of cool things. Yeah, thanks. Bye.